Oh, I don't know, mate. I think the other shot was better.
Fine, if you're so sure, you Australian son of a...
Hey, Cracky, we're on.
Hi, I'm Ned Flanders, and I'm here at Ronnie Bentz's press conference. Sorry about that, folks. I'm Ned Flanders, and I'm here at Ronnie Bentz's press conference on the beautiful, clean-smelling, sandy beaches of Lexington, Nebraska, where Big Ronnie Benson is introducing his new cologne, Stavi. You may be wondering why I'm whispering. Well, last time I got too loud at Ronnie's press conference, and, well, some went down. Anyway, we're getting word that Rodney is coming out right now.
First off, I just want to tell everyone out there, I was around about the whole cologne thing.
So, no cologne?
That's a Big 10-4.
Well, in that case, Rodney, associates, a bachelor's, a master's, and a PhD, and an MD in being a badass. At Harvard, in the course of 2 years, as well as being the youngest man to earn $1 trillion, we have to ask, what's next?
I'll bet you'd like to know, wouldn't you?
What?
Next question.
So, Rodney, I was wondering if...
Why the f*** are you whispering?
You struck me last time, sir. I'm afraid of speaking too loudly. Anyway, sir, Mr. Rodney, are Mr. Barnard's rumors about you not completing your homework true?
Homework? You talking about homework? Not the test. Not the test. We're talking about homework right here. Homework. Not the test. Not the test we study all week for that matters. We're talking about homework, right? Am I right? Answer? Jeez. We're talking about homework? Who the have you been talking to?
So, Rodney, we all know about integration, how it's the process of finding a function when given the derivative, but how are you able to integrate so well on a daily basis?
Really? Oh, I'm sorry. I thought you were reporters, not dumb. That question is like asking a skunk how it swims so real good. Dumb question. Next. You in front.
Alright, we all know what summation is.
Wait. No, him back there. I meant him back there. That guy, yeah, that guy.
Am I doing this right? Alright, in order to integrate a function, you can use the basic formula of x to the n. Integrated would be x to the n plus 1 divided by that new power. So this one would be 8x to the 4th over 4 minus 5x plus c to represent a constant that was canceled out due to taking the derivative of the original equation, and that simplifies down to 2x to the 4th minus 5x plus c. And sometimes when finding the integral, you can also find what c would equal if they give you a term of the function. So we have the derivative of this function when you plug in 3 equals 11, and our derivative is 6x minus 3. So if we integrate this, we'll get 3x squared minus 3x plus c. And then, so if we plug in 3, we'll get 3 times 9 minus 3 times 3 plus c, and that's supposed to equal 11. So multiply everything out, we get 27 minus 9 plus c equals 11. Simplify 18 plus c equals 11. So our c would equal negative 7. Plug that back into this, so we get 3x squared minus 3x minus 7.
So, Rodney, can we see one of your world-famous summation formulas?
Wouldn't you like to know? The first thing you got to remember when you're doing summations is plugging in numbers. So, it starts at x equals 1, so you're going to plug in a 1 here. 2, or x squared, 1 times 1 is 1, times 2 is 2, minus 1 would be 1. And then you're probably going to plug in 2. 2 times 2 is 4, times 2 is 8, minus 1 is 7. And plug in 3. 3 squared, 9, times 2, 18, minus 1, 17. So 1 plus 7 plus 17 gives you a grand total of 25.
Rodney, with the rules of the game changing so quickly.
Wait, what did you say?
The rules are changing quickly.
The rules have not changed! They're exactly the same as they were 2,000 years ago!
Come closer. No, closer. I don't want Rodney to get mad and yell at me again.
I dare you!
Anyway, for summations, you have a couple rules. And according to Rodney, they haven't changed in 2,000 years. Those rules are, for when I is equal to 1, the constant is times your top number. So the constant is constant times n. For when it's just I, you're going to take the top number times the top number plus 1 over 2. Are you with me? For I squared, you're going to take n times n plus 1 times 2n plus 1 over 6. And then for I cubed, then when you have I cubed, you're going to square n times quantity n plus 1 squared over 4. Are you with me? Alright, now we're going to do an example with the n value being 10. Now, n can equal any number, but we're just going to use 10 for this example. Now, there's an x squared, so we're going to use the I squared rule, which, if you remember, hasn't changed from 2,000 years ago, so it hasn't changed from 5 minutes ago. And it's going to be n times n plus 1 times 2n plus 1 over 6. So in this case, it's going to be 10 times 11 times 21 over 6 times constant rule, Cn 2 times 10 plus 20. So this can get to a 5. Well, this is a 3. This could go to a 7. Well, this cancels out completely. So it's 5 times 11, which is 55, which is 55 times 7, which is 385, plus 20, giving you the final answer of 405.
Well, over the break, we got a very angry phone call from my sponsor, Barnard's Book Publishing, saying they'd terminate my contract if I don't control my language a little more. So even though that's complete bull, I will try to clean it up just a tad.
Hey Rodney, with your mixer in Santa Barnard this weekend, you're going to be bringing in some definite girls, right?
Did you say definite integrals?
No.
Alright, for definite integrals, there are some simple rules to follow that'll make them a lot easier to solve. First of all, if your lower limit and your upper limit are the same, your function will equal 0. If your lower limit and upper limit have been switched, you will get a negative answer. You will get the opposite answer to your function. If you have a constant in front of your function, you can pull that constant out, solve for it, and then multiply by the constant. And then if you have two functions in the same summation with the same boundaries, you can do those separately and then add or subtract them together. So let's put the rules to some work. Alright, so we have boundaries 3 to 3 of the functions x squared plus x plus dx, but since we have the same upper and lower limit or boundaries, that would just be 0. And then we have this one where our lower boundaries are different, but we know the information, so 2 times 1 squared, or 2 times 1 would be 2, minus 35, 7 times 5, plus 4 times 3, 12, would give us negative 21. And then we have two problems with different boundaries, but we still have the information. So our x squared, 4, minus 7, negative 3.
So Rodney, are you worried about your upcoming steel cage match with Captain Bones in the Garden?
Captain Bones? Are you kidding me? That guy might as well go buy a rowboat and sail around the world with his first mate, Sammy the Scorpio. You've just discredited the phrase, there's no such thing as a dumb question. Come on, guys. This guy's a joke. Next question.
But Rodney, what about your MMA fight with the Scraggle twins in Monte Carlo in 4 months?
All I gotta say, these two things right here. All I gotta say to those guys, it's gonna be a Scraggle Goat beatdown.
Rodney, between being a stud, a quadzillionaire, a big-time athlete, and an overall total bad A, don't you just get exhausted?
I'll tell you what really gets me exhausted. The exhaustion method. Take it away, Frank.
It's chives, sir.
No one cares, Frank.
Okay. To find the area under a curve, you have to find your width and height first. And so to find the width, you take your upper boundary, subtract it from your lower boundary, and divide it by n. To find your height, you just take your width times I plus the starting boundary, which is 0, so it's just 7i over n. And then you have to take length, or width times height, right there. And then plug that into the formula using f of x. Get that. Get common denominators. More common denominators. Take out an n, so it's easier to simplify. Then you have to use the I rules, which apparently haven't changed for 2,000 years. And so you have 14n times n plus 1 over 2 plus 7n squared, because you have to use the constant rule to get another n. And then multiply all that out, reduce it down, so you have 7n squared plus 7n plus 7n squared. Then combine them, because less is more, and get that. And then you just run the 7 through and the n squared through, get 98n squared plus 49n squared, all over n squared. Then you just turn it into a limit problem. So you get, as n approaches infinity, to get 98n squared over n squared plus 49n over n squared, and that would give you 98 as the area under the curve.
So Rodney, how are your kids?
Well, at the start of the press conference, I did say I was not going to answer any questions about kids, but I'll let it slide. This recently left us. He thought it'd be funny to go SeaWorld drunk while trying to pee in the Penguin Emporium. He fell in, and yeah. This is all that's left of those penguins now.
It's recap time! Alright, quick rules for everything we've done so far. Basic power rule of integration. X to the n will equal x to the n plus 1 divided by that new power plus the constant c. And then here are trig functions that you can integrate. Cosine of x dx equals sine x plus c. It's just the opposite of all the derivatives of the trig functions. And then summation formulas for like the exhaustion method and stuff. C equals cn. I equals n times n plus 1 divided by 2. I squared n times n plus 1 times 2n plus 1 over 6. And I cubed is n squared times n plus 1 all over 4. So Rodney, to wrap this press conference up, would you say you're the biggest bad A of all time?
I think we've basically covered this. I can't believe you're asking, you have to ask this question. We spent this whole press conference discussing what a total bad A I am. And you ask me this? This is ridiculous. I'm out of here.
Mac, I'm gonna. A millionaire, I'm a young money millionaire, tougher than Nigerian hair. My criteria compared to your career just isn't fair. I'm a veneer.
Insurgents, either forced to join their militia.